We're going to talk about sectors of circles and then finding their area. So the first thing we want to know is, what is a sector of a circle? A sector of a circle is the interior portion of a circle that is cut off by two radii. So for example, in this picture, we have actually two sectors. We have the sector that is highlighted in yellow, and we have the sector that isn't highlighted, that's all white. So those are two sectors of this circle. A sector of a circle, once again, is the interior portion of a circle that's cut off by two radii. Now, if we're finding the area of a sector of a circle, what we would do is we would find the area is spelled A-R-E-A. We take the area of the circle, and then we multiply it by the angle, the central angle, divided by 360 degrees. So another way to think about that is the area of the circle multiplied by the fraction of the circle that we're dealing with. So we know that the area of a circle is pi r squared, and then we're going to multiply it by the fraction of the circle that we're dealing with. So for example, in the problem that is here with the 90-degree angle and a radius of 8, if we are trying to find the area of this shaded region, what we would do is we would do pi times 8 squared, and then we would multiply that by 90 over 360. Likewise, we also could understand that a 90-degree angle out of 360 degrees is really just 1/4 of the circle. Now, if you reduced 90 over 360, you would get 1/4. So you could do it either way. You could use the angle over 360, or if you can reduce that into a smaller fraction, it might be a little bit easier for you to calculate. So 8 squared is 64. 64 pi times 1/4, which is 64 pi over 4, that's 16 pi. So the area of this is 16 pi units squared, which, if I wanted to type it in the calculator and get a rounded answer, that would be 50.265 units squared. Problem 2. This area that's shaded has a diameter of 18, so that means my radius is 9. Then I have a 60-degree angle, so I'm going to do the area of a circle, or the area of this circle, which is pi times 9 squared. Then we're going to multiply that by the fraction of the circle that we're dealing with, which is 60 over 360. So 9 squared is 81. I have 81 pi, and then I'm going to multiply that by 1/6. Notice that 60 out of 360 is exactly 1/6 of the circle. So if I cut the circle into 6 equal parts, I would get exactly that shaded region. So I end up with 81 pi over 6 units squared. Notice that both of those are divisible by 3. So I have 27 pi over 2 units squared. And if I wanted, or 13.5 units squared, 13.5 pi units squared. And if I wanted to get a decimal approximation for that, it would be 42.412 units squared if I typed it in the calculator. 2 more problems. Problem 3, I have a radius of 14, and then this angle is 135 degrees. But notice that the shaded part is the bigger part. So I can't just use the 135. I have to use 360 minus 135 to figure out what that angle is. So that's a 225-degree arc or central angle if you want to think about it that way. And so that's what we will be using. So I'm going to have pi times 14 squared times 225 over 360. So if I'm doing that, 14 squared is 196. So I have 196 pi. And then 225 is really 5/8 of the circle. That's not something that you're expected to necessarily know off the top of your head, but I have 196 times 5 over 8. So if I wanted to get an exact answer, I'd have 122.5 pi units squared. And if I wanted to get a rounded decimal, I would get 384.845 units squared. So either one of those would be acceptable based on whether it was exact or rounded. Finally, this one has a radius of 11. So I have pi times 11 squared times 156 over 360. Now 156 over 360 is not, I mean, it does reduce a little bit, but it's not something that's like super easy to deal with. So I'm just going to type this in the calculator. I get 121 times 156 over 360. And then I'm going to multiply that by pi, 164.724 units squared.